In this lesson, we're going to be talking about basically the same thing we did in lesson 2.3, but now you're going to be given your information, like your line, the equation of your line, in the different forms. So there's lots of different ways that you can be given information, and then you'll have to identify the slope. The first way is if you're given 2 points. And if you are given that, you want to use the slope formula, which is y2 minus y1 over x2 minus x1. So that's if you're given two ordered pairs. If you're given point slope form, you want to look for the m, which is in front of your set of x parentheses. That represents your slope. In slope-intercept form, you're looking for the coefficient on x, or the number in front of x. And then in standard form, there's two ways you can do this. The first way is that you can solve it for y and put it into slope-intercept form, which is y equals mx plus b. The second way, and I'm going to do a little bit of scratch work here at the bottom, there is a shortcut. You'd have to have it memorized. If I solve this as is, so I'm not going to have any numbers in here, I would have negative ax plus c, and then I would have to divide by b to get everything by itself. So now I'm in slope-intercept form, so negative a over b x plus c over b. So the shortcut is this. If you are in standard form, the shortcut is that you can use your letters, so you would take negative a over b. So as an example, if I gave you 3x plus 5y equals 10. 3 is the a, 5 is b, so your slope would be negative a over b. So it would be negative 3 over 5. So if you're in standard form and you can remember this little shortcut equation, that'll take you straight to your slope. We want to write the equation of the line that is parallel to this line that we're given right here and passes through the point negative 5, 1. So just like we did in 2.3, the first thing I want to do is identify the slope of the given line. So this one is not as straightforward as the ones in lesson 2.3 because I have to do a little bit of work before I can actually get to my answer. So what I'm going to do is I'm going to take this and I'm going to divide everything by 2 so that I can get y by itself. So I have y equals 3x because 6 divided by 2 is 3, and then plus 6 because 12 divided by 2 is 6. Okay, so the slope of this line is 3, but I'm looking for a line parallel. So I need to now identify the parallel slope. So the parallel slope, which is the one I'm going to be using, so parallel slope is also 3, because when two lines are parallel, they have equal slopes. So now I can move to setting up my my point slope form. So just as a reminder, in case you forgot, point slope form looks like this. Y minus y1 equals m times x minus x1. So I'm going to plug in my slope, which is 3 for the m, and then I'm also going to leave blanks for y1 and x1. So y minus y1, I don't know why I just put parentheses there. My slope is 3, and then x minus x1 will go in here. So this is my point right here, negative 5, 1. I'm going to put in negative 5 for x1 and 1 for y1. So here's my 1 and then my negative 5. So since I have a negative 5 in my parentheses there, it's actually going to turn into x plus 5. So let me rewrite this. Y minus 1 equals 3 times x plus 5. All right, next I need to simplify. So I'm going to distribute. So I'm going to distribute this 3 to the x and the 5, and I have y minus 1 equals 3x plus 15. And then last but not least, I'm going to add 1 to both sides. So I have y equals 3x plus 16. So this is my final answer. Same process as the slide before. The only difference here is that now we're looking for a perpendicular line. So that's going to change our slope situation a little bit. So the first thing I'm going to do is get this into slope-intercept form by dividing everything by 2. And this is really what I care about right here. I know it looks like the slope might be 2, but since the 2 is in the denominator, it's going to be a fraction. And there's actually an invisible 1 here that you don't have to write. But if you add it in there, it makes it a little more obvious that the slope here is 1/2. So I don't want the slope of 1/2 though. I want a perpendicular slope. So remember that it has to be an opposite reciprocal. So the first thing I notice is that 1/2 is positive, so my perpendicular slope will be negative. And then I have to take the reciprocal of 1/2. And the reciprocal of 1/2 is 2/1, but I could just leave it as -2. I don't have to make it, it doesn't have to be a fraction. So that's the slope that I'm going to use and plug into my point slope form. So now I'm going to set up my point slope form, and I'm going to leave my blanks where x1 and y1 go. Okay, so now here's my point x1, y1. It's -4, 1. So when I plug this in here, y minus 1, and then this would be x minus -4, but I'm going to skip a step and just go straight to writing x plus 4. So what you can really think of this as, when you plug in these numbers, you're just putting in the opposite sign. So if it's a negative number, it's going to turn positive, and if it's a positive number, it's going to stay negative or become negative when you put it into the formula. So now we have to distribute and simplify. So I have y minus 1 equals -2x, and then -8 because I have a -2 times a positive 4. I'm going to add 1 to both sides, and I end up with y equals -2x minus 7, and that's my final answer. Now we're going to write the equation of a line, and it's perpendicular to something, and this is actually in standard form because it's of the form ax plus by equals c. So we can use that little shortcut that I showed you to find the slope, or you can simplify it and put it into slope-intercept form and then look for the number in front of x. Either way, we should both get the same answer. So I'm going to use that shortcut just so you can see how that works. So a is 3 and b is 4, and if you remember, that little shortcut was -a over b. So I'm going to do -3 over 4. So that is the slope of the line we were given, but we want a perpendicular slope. So a perpendicular slope would be the opposite reciprocal. So since my original slope is negative, my opposite reciprocal slope will be positive. And then I need to take the reciprocal of 3/4, which is 4/3. So this is the slope that we're going to use in the formula. All right, so I'm going to plug my points in now. So I have y minus y1 equals slope times x minus x1. And this is a minus sign here. I just wrote twice for some reason. Okay, so the point I'm plugging in is 2, -9. So remember, we're going to do the opposite. So since I have a -9, it's actually going to be y plus 9. And then I have a positive 2, so it's going to be x minus 2. And now I have to do some simplifying here. So I have y plus 9 equals, and then I'm going to distribute the 4/3. So I have 4/3 x minus, and then it would be 8/3. And if you want to plug that into your calculator, you can. Over here, I'll just show you how I did that. So if I did 4/3 times 2, this is really 2/1, and then you multiply across. So 4 times 2 is 8, 3 times 1 is 3. To simplify completely, I have to subtract 9 from both sides. So I have y equals 4/3 x. And I know this is going to be minus, but over on the right, I'm going to do some scratch work in light blue. So I'm not going to worry about the signs, but I want to figure out how to do 8/3 plus 9. So I need a common denominator. That means I'm going to multiply my second number by 3/3. So I have 8/3 plus 27/3. And then when I add 8 and 27, I would get 35, and then over your common denominator. So that's the number that's going to go right here. You are more than welcome to plug that into your calculator, and you'll get the same answer. All right, so now we're on to applications, which is essentially the exact same thing, but you have to be able to pick out the information from the scenario that you're given. So we're talking about plans for a building that are being drawn on a coordinate grid. One of the support beam lies on the line 5x minus 8y equals 11, and a perpendicular brace passes through the point -4, -1. So we're looking for an equation of a line that contains the brace. So this is exactly the same thing as the previous few slides have been. So here's my equation, 5x minus 8y equals 11, the first thing I need to do is figure out the slope. So I'm going to use that shortcut, negative a over b. So 5 is my a, and I'm going to make it negative because that's part of the formula. And then b is negative 8. So my slope here is actually 5 over 8. But I'm looking for a perpendicular slope. So my perpendicular slope would be the opposite sign, which is negative, and then the reciprocal, which is 8 over 5. So that's the slope that I'm going to use in point slope form. And then I'm going to have to plug in my x1 and y1. So x1 and y1 are negative 1 and negative 4. So when I plug them in, they're actually going to turn into positives. So this is going to be y plus 1, and this is going to be x plus 4. So now we have to do some simplifying. So I have y plus 1 equals negative 8/5 x. And then I'm going to do a little scratch work over here. I know it's going to be negative because I have a negative times a positive. So let's just do 8/5 times 4. So again, that's like 4 over 1. So this would be 32 over 5. Okay, and now last thing I need to do is subtract 1. So I have y equals negative 8/5 x. And then I'm going to do some more scratch work over here in light blue. So I have 32 over 5 and 1, which I need to get a common denominator. So I'm going to multiply by 5 over 5. And I get 32 over 5 and 5 over 5. So even though I'm subtracting them, since they're both negative, what it's really like I'm doing is I'm adding them. It's just that my answer is going to be negative. So if I added 32 and 5, I would get 37. So this is going to be minus 37 over 5. And that's our final answer. All right, so now we're going to try something a little different. So on the graph there, we're given an equation, and then we're also given a point. And it wants us to write a line, an equation of a line that is parallel and an equation of a line that is perpendicular. So the first thing I want to do is get the same information that we've been using this whole time, which is the slope of our original line and then the ordered pair of the point. So let's go over to this graph here. To find slope, I want to find two nice points. So it looks like this is a good point, this is a good point, and then I need to count rise over run. So if I count up from my point, I had to go up 5 and then right 1. So the slope of my line is 5 over 1, or you could just say 5. And then we also need to identify the coordinates of this point here. So it looks like it's left 3, which is negative 3, and up 5. So the point negative 3, 5. So now at this point, I have everything that I need to know. For the first question, it asks you for a line parallel. So the parallel slope is the same, so it's also 5. And then let's just go ahead and do the perpendicular slope. So since the parallel slope is positive, my opposite reciprocal will be negative, and then if I flip 5, it would turn into 1/5. And you can kind of see that a little bit better down here before I changed it into a whole number. Okay, so now we just have to do the simplifying twice. So the first would be y minus, and then our slope is 5, x minus blank. And then what I'm plugging in for x1 and y1 are negative 3 and 5. So this is going to be y minus 5, and this will be x plus 3, because it's going to give you a double negative. So now we just have to simplify. So I have y minus 5 equals 5x plus 15, and then I'm going to add 5 to both sides. So my final answer would be 5x plus 20. So that's my parallel line. And then my perpendicular line, I'm going to do the exact same thing, but instead of 5 for my slope, I'm going to put in negative 1/5. So everything else is the same. I'm going to just copy it down, except now my slope is negative 1/5. So now I have to simplify. So I get negative 1/5 x minus 3 over 5. And then I need to add 5 to both sides. So I have y equals negative 1/5 x, and then over on kind of the bottom underneath here, I'm going to do a little scratch work. So I have negative 3/5 plus 5, which I need to turn into having a denominator of 5. So So I have negative 3/5 plus 25 over 5. Negative 3 plus 25 is 22 over 5. So I'm going to have plus 22 over 5. So this is the answer for my perpendicular line. An architect uses software to design the ceiling of a room. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam, which is represented by the line drawn. This new beam will pass through the corner represented by the point. What is an equation that represents the new beam? So I want the red thing that you can see here, the existing beam, we want a line that is perpendicular to that beam, and we want it to go through the corner of the room. So this point right here, let me see what would be the easiest color to see. This is the point we're talking about right here. That's what it needs to go through. And then it needs to be perpendicular to the existing beam. So let's first figure out this ordered pair. It looks like 12, 10. So that's our point, x1, y1. And then we also need to figure out the slope of the existing beam by counting rise over run. And then we'll take the opposite reciprocal of that. So I think the easiest thing to do actually would be to use this point here and this point here. I know that there are other points that we could use, but those are very clear-cut points. So I would go up 8, and then I would go, oops, I didn't go up 8. Up 8, and then we're going left 12. So my slope would be, the rise is positive 8, and the run is negative 12. So if we simplified that, everything's divisible by 4. So it would be negative 2/3. So that's the slope of the existing beam. I want the perpendicular slope. So I'm going to take the reciprocal, and I need the opposite sign, which is positive. So this is what we're going to plug into the formula. And then again, up here, this is our x1 and y1. So over on the right-hand side here, I would have y minus blank. Our slope is 3/2, x minus blank. The things we're plugging in are 10 and 12. So now I'm going to simplify. Y minus 10 equals 3/2 x. And then if I multiplied 3/2 times 12, it would give me 18. And now I'm going to add 10 to both sides. So I have y equals 3/2 x minus 8. So this is the new beam that they want to install.